Hello and welcome to Electro Nerds Academy. In this lesson, we'll explore Pulse Width Modulation, PWM, what it is, how it works, and how Arduino can generate PWM signals. PWM works by rapidly switching a digital pin on, outputting 5 volts, and off, outputting 0 volts within a given time period. The resulting PWM signal looks like a series of rapid pulses. On a graph with voltage on the y-axis and time on the x-axis, you will notice that the signal repeats itself after a certain period. This repeating interval is called the time period. Another important concept in PWM is the duty cycle, which represents the percentage of the time period during which the signal is on or high. For example, if the signal is high for 50% of the time period and low for the other 50%, the average output voltage would be 50% of the maximum voltage, resulting in 2.5 volts. If we increase the duty cycle to 100%, meaning the signal is always on or high, then the average output voltage will be 100% of the maximum voltage, resulting in 5 volts. Conversely, if we decrease the duty cycle to 0%, meaning the signal is always off or low, then the average output voltage will be 0% of the maximum voltage, resulting in 0 volts. By adjusting the duty cycle, you can control the average voltage output, which can be used to dim LEDs, control motor speed, and more. Most Arduino boards have dedicated PWM pins. On an Arduino Uno, these are typically marked with a tilde next to the pin number. So pins 3, 5, 6, 9, 10, and 11 are PWM pins. To generate a PWM signal on Arduino, we'll use the analogWrite function. It requires 2 parameters, the PWM-capable pin on the Arduino board and the duty cycle value. This value is an 8-bit number, ranging from the lowest 8-bit number, which translates to 0 in decimal, producing 0% duty cycle, creating 0 volt signal, to the highest 8-bit number, which translates to 255 in decimal, producing 100% duty cycle, creating 5 volt signal. Values in between adjust the duty cycle proportionally, controlling the average voltage output. Let's see this function in action with a small project. We'll control the brightness of an LED as shown here. For this, we connect the LED's anode to pin 9 of the Arduino, which is a PWM-capable pin, and the cathode is connected to the ground pin through a 220 ohm resistor. Now let's move on to the programming part. Here we'll use a built-in Arduino example sketch called Fade. For this, we will go to the File menu, then navigate to Examples, and under the Basic option, we will select our example Fade. A new window will open with the code. Let's break the code down line by line. We start by declaring 3 integer variables. LED stores the pin number where our LED is connected, pin 9. Brightness keeps track of the LED's brightness level, starting at 0. And fade amount is set to 5, which controls how much the brightness changes at each step, meaning at each iteration of the void loop. Then, in the setup function, we configure pin 9 as an output pin. Next, in the loop function, we use the analogWrite function with 2 parameters, the LED variable, which holds the pin number, and the brightness variable, which holds the brightness value. This value can range from 0 to 255, since it controls the duty cycle of the PWM signal. A value of 0 means the LED is completely off, while 255 means it's fully on. After that, we increase the brightness value by adding fade amount. So when the loop is run for the first time, the brightness changes from 0 to 5. With each iteration of the loop, brightness increases in steps of 5 until it reaches the maximum of 255. To prevent the brightness from going out of range, we use an if statement to check whether brightness has reached 0 or 255. If it has, we reverse the direction of fading by multiplying fade amount by -1. For example, when the value of the brightness variable reaches 255, one of the conditions in the if statement becomes true, causing the fade amount to change to -5, and the LED gradually fades back down to 0. When the brightness value reaches 0, the first condition in the if statement becomes true, causing the fade amount to reverse again, making it +5, and the whole cycle continues. Finally, we add a short 30 millisecond delay to make the fade effect smooth and visible to the human eye. After uploading this code to the Arduino, you'll notice the LED on pin 9 smoothly fades from fully off to fully on, and then back down again, repeating this cycle endlessly. Now let's add a potentiometer to this circuit so that we can control the brightness using it. We will connect one outer terminal of the potentiometer to the 5 volts pin of the Arduino and the other outer terminal to the ground pin. And the wiper is connected to analog pin A0. Now let's write the code. We start by declaring 2 constant variables named pot pin and LED pin to store the Arduino pin numbers connected to the potentiometer and LED, which are A0 and 9 respectively. Next, we declare 2 integer variables, PWM value to store the converted PWM values, and pot value to store the analog readings from the potentiometer. In the setup function, we configure the LED pin as an output and the potentiometer pin as an input using the pin mode function. Moving on to the loop function, we first read the potentiometer value using the analogRead function, passing pot pin variable as the parameter, and store the result in pot value variable. After a short delay, we convert the analog readings ranging from 0 to 1023 into PWM values ranging from 0 to 255 using the map function. The map function takes 5 parameters: the value to be mapped, the minimum and maximum values of the current range, which are 0 and 1023 in our case, and the minimum and maximum values of the target range, which are 0 and 255 for PWM output. It returns the mapped value in the target range, which we'll save in the PWM value variable. Finally, we use the analogWrite function to output this PWM value to the LED pin. Now, let's upload this code to our Arduino. Once uploaded, rotate the potentiometer knob and observe how the LED's brightness changes accordingly. So that's all for this video. We hope you find it helpful. Be sure to check out our channel and visit our website for more content like this, and we will see you in the next one.